अस्सलाम वालेकुम सर।
Walaikum assalam warahmatullah. Actually, so let us start with ethers. Ethers, okay. Now I will start with a bit of nomenclature here because the nomenclature of ethers is a bit unusual. It's not like the rest of the organic molecules. For example, if I have CH3, O, CH2, CH3, then this will have a IUPAC name and also a common name. And common name is generally more used. Okay. So if I talk about the IUPAC name, then it is going to be, this is the main chain and this is the substituent. So here we have two carbon atoms. So IUPAC name is going to be ethane. Right, my bad. First of all, substituent, it is methoxy, methoxy, ethane. The common name for this is going to be, first of all, if you identify this molecule is ether. And what of the substituent it is having? It is having a CH3 group and it is having a CH2 CH3 group. So it is having a methyl group and is having an ethyl group. So we can say it is an ether which has methyl. It has an ethyl group. So we can say that this is an ether which has ethyl and methyl group. So इसका नाम क्या हो जाएगा? The name is going to be ethyl methyl ethyl methyl ether. ठीक है? Similarly, if you have CH3O CH3, this is going to be what? It's going to be dimethyl ether. Fine. Now there is one ether that is very important. So for example, you have carbon here, and this carbon atom has three CH3 groups. Now this group is tert butyl. So what we will name it? We will name it di tert butyl ether. ठीक है, चलिए, write this down. Raise your hand once you're done. Done, everyone? Who's still writing? Aslan, done?
Yes sir.
After this, we will start with the routine work, that is method of preparation of ethers. Now, please see. First method of preparation is dehydration of alcohol. Dehydration of alcohol. Now, in dehydration of alcohol, we have also seen this in the chemical properties of alcohol, but there we saw dehydration at higher temperature. So for example, if you have CH3, CH2, OH, and you use H2SO4 at higher temperature, for example, 443 Kelvin, then in that case, you're going to get alkene, that is CH2 double bond CH2. So this is an alkene that you get via elimination reaction. That you get via elimination reaction. But if I use the same reagent, H2SO4, and we keep the temperature 414 Kelvin, then you will get CS3, CH2, O, CH2, and CS3. Okay, so in this case, you are getting ether. And substitution reaction occurs in this particular case. If you look at the NCERT, the exact temperature that we need is exactly 413 Kelvin, not 414. But I write it 414 because it looks like ether to me. है ना, देखिए जैसे ROR is the general formula for ethers, 414 ROR. ठीक है. So if you ever get confused, that is why I never write 413, 414 Kelvin ही लिखते हैं, and no one is going to do it wrong because 1 Kelvin का difference, it's not going to make any difference, right? So for H2SO, when we have ethanol, it is treated with H2SO4 at 414 Kelvin. We will get ether via substitution. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
Okay. And you will have a general reaction, that is alcohol. It reacts with H2SO4 at, अभी यहाँ पे हम 413 Kelvin लिख दे रहे हैं. Just to remember, you need to remember 414. You will get ROR. Please write this down. Raise your hand once you're. Done, everyone?
Yes,
सबने
sir.
कर लिया है? ठीक है. चलिए. Write 2 points and then you write questions. Ethers having same alkyl group on either side of oxygen atom is called symmetrical ether. It's called symmetrical ether. Okay. So dehydration of alcohol with concentrated H2SO4 at 413 Kelvin gives symmetrical ethers. You just need to identify the alkyl group attached. For example, if you have CH3OH, the presence of H2SO4 at 413 Kelvin, it is going to give you CH3OCH3. Okay, when you have 2 carbon atoms and OH, then what you will get? 2 carbon atoms, oxygen, and then again you will have 2 carbon atoms, ether. Similarly, जब आपके पास 3 carbon atoms आ जाए, and then OH, the presence of H2SO4 at 130 to give you 1, 2, 3 carbon atoms, oxygen atom, and then again 1, 2, 3 carbon atom. Write this down. Raise your hand once you're done. Let us see the mechanism for this reaction. So we will do the mechanism of CH3, CH2OH, the presence of H2SO4 and 413 Kelvin. It gives you CH3, CH2, O, CH2, CH3. Okay. So the number one step is protonation of alcohol. In protonation of alcohol, well, first of all, you have OH. In the presence of H2SO4, there will be H plus ion in the solution. This H plus ion will be attacked by the lone pair of oxygen atoms, leading to formation of protonated alcohol. That means the alcohol is as it is, and it is having one more hydrogen atom. Now this oxygen atom will have a positive charge. Next is the attack of nucleophile. Attack of nucleophile. Now, see, in the first step, some of the alcohols are attacking the H plus atom. Some of the alcohols will be still remaining. So those alcohols, they will attack onto this particular species. You have O, you have two hydrogens, and then with positive charge. Now this oxygen atom, it is attacking on this carbon atom. This carbon then leaves bond. And then here you will get two carbon atoms, oxygen. This oxygen is attacking in this carbon atom, and it is further bonded to another carbon atom. So again, it is bonded to two carbon atoms. This oxygen already has a hydrogen atom like this. Now this oxygen has a positive charge. In the last step, deprotonation occurs. In deprotonation, we have hydrogen and O positive. This hydrogen gives the electron density to oxygen atom, and we get ether, and the H plus is liberated as it is used as a catalyst. तो जैसे यहाँ पे आया था, similar way H plus is left. Now again H plus may actually there is some attack happening on the this hydrogen atom. It will be majority of the times from this alcohol itself, because there will be some alcohols remaining. Those alcohols will attack on this hydrogen atom, and then it will get protonated like this. ठीक है? So deprotonation यहाँ पे जो हो रहा है, this deprotonation is actually a protonation of some alcohol. ठीक है? Will you write these three steps? Now these type of mechanisms are directly asked. Raise your hand once you're done, guys. Aslam, Krishna, Priyan, Safia. Raise your hand once you're done.
Sir,
Yeah, tell me.
आपने कहा कि ये दिस काइंड ऑफ मैकेनिज्म आर आस्क्ड डायरेक्टली, तो इनडायरेक्टली कैसे पूछेंगे?
इनडायरेक्टली वो कैसे पूछेंगे, वो रिमार्क्स में आएगा. ठीक है? देखिए जैसे ये स्टेप जो है ना, अटैक ऑफ न्यूक्लियोफाइल, ये SN2 रिएक्शन है. ठीक है? नाउ इन SN2 नो यू नो व्हाट इज द ऑर्डर ऑफ रिएक्शन. दैट मीथाइल सबसे ज्यादा फास्ट होगा, फिर उसके बाद 1 डिग्री, फिर उसके बाद 2 डिग्री, फिर उसके बाद 3 डिग्री. राइट? ठीक है? तो वो इनडायरेक्टली पूछ सकते हैं ऐसे. मेक सेंस?
यस, थैंक यू.
Now please write some remarks. In remarks, you'll write number 1 point. It occurs via SN2 mechanism. Therefore, the rate of reaction is methyl alcohol, that is CH3OH, will be fastest, followed by 1 degree, followed by 2 degree, and then followed by 3 degree. Now, 2 degree and 3 degree when we use, please write the second point, 2 degree and 3 degree alcohol gives significant amount of alkene with ether, as they are more hindered. As they are more hindered, therefore, this method of preparation is not suitable for formation of symmetrical ether using 2 degree and 3 degree alcohols. Okay. Now, a general question is asked is why we cannot prepare di-third butyl ether using dehydration of alcohol. So in that case, you will write this line. 3 degree alcohol gives significant amount of alkene with ether as they are more hindered. This is the line. Because here you can see, this carbon atom, it is what, 3 degree. So for 3 degree ether, we would require a 3 degree alcohol also. And 3 degree alcohol is going to give you alkene and not ether. Another point regarding this method of preparation is, please write with me. The third point, this method of preparation is not suitable for preparation of unsymmetrical ethers, as it would require 2 different alcohol and lead to formation of mixture of ethers. Mixture of ethers difficult to separate. ठीक है, इसको थोड़ा आसानी से समझ लीजिए, ध्यान दीजिएगा जरा. Please don't write now. Listen very carefully. Let us suppose you have 2 carbon atoms, oxygen and then CH3. तो जब आपके पास CH3OCH3 था, then you required only one alcohol, that was CH3OH. So CH3OH में ऐसे कार्बन एटम भी फिर से अटैक करके CH3OCH3 बन जाता था. But when you have an unsymmetrical ether, that is CH3, CH2O, and then CH3, then in that case, we would require 2 alcohols. The 2 alcohols will be ethyl alcohol and methyl alcohol. So when you have ethyl alcohol and methyl alcohol, and you treat this with H2SO4 at 413 Kelvin. Now, one thing is for sure that some of the ethyl alcohol will react with methyl alcohol and it is going to give you this particular product that you require. But a large amount of ethyl alcohol will not even collide with methyl alcohol because uske surrounding mein jaise maan lijiye, like imagine pouring na, you have methyl alcohol, ethyl alcohol and H2SO4. So as you are pouring the methyl alcohol into H2SO4, what is going to happen? In that case, जो ethyl alcohol है वो ethyl alcohol के साथ ही रहेगा and then it will attack onto itself, leading to the formation of diethyl ether and many of the methyl alcohol will react with itself, leading to formation of dimethyl ether. Does this make sense? Yes or no? Please tell me, guys.
Yes, sir.
ठीक है, तो इसमें जो सवाल आता है ना, सवाल थोड़ा सा अलग आता है. सवाल इस तरह से आता है, बाई मॉलिक्यूलर डिहाइड्रेशन ऑफ बाई डिहाइड्रेशन ऐसे इज नॉट अ सुटेबल मेथड. ऐसे हुआ, इज नॉट अ सुटेबल मेथड टू प्रिपेयर इथाइल मिथाइल ईथर. वाई. ठीक है, तो आप क्या लिखिएगा आंसर में? बिकॉज इट गिव्स मिक्सचर ऑफ ईथर्स. ठीक है, और उसके बाद ये रिएक्शन ना, देखिए हमको क्या बना था, इथाइल मिथाइल ईथर. सो वी कैन नॉट यूज डिहाइड्रेशन ऑफ अल्कोहल बिकॉज ऑफ दिस, है ना. चलिए प्लीज कॉपी दिस डाउन, रेज योर हैंड वंस यू आर डन. Just waiting for Arsalan now. Done everyone. ठीक है. Now right next. Right here. Or are we writing the names blue or blue? Second method of preparation. This is very important. There is not a single examination of chemistry 12th standard इसमें कि इस टॉपिक से सवाल नहीं पूछा गया है. ठीक है, सो इट इज मोर इम्पोर्टेंट देन कंप्लीट अल्कोहल फिनॉल ईथर चैप्टर में अगर आपने प्रिपेयर किया है एंड यू हैव नॉट स्टडीड दिस पर्टिकुलर पोर्शन, दैट मींस यहीं से सवाल आएगा. ठीक है, इट्स वेरी इंपॉर्टेंट. फ्रॉम alkyl halides. This is also known as Williamson ether synthesis. Williamson ether synthesis. Williamson ether synthesis. Now please write the statement. When haloalkane is treated with suitable sodium alkoxide, sodium alkoxide, an SN2 reaction occurs, forming corresponding ether. So basically we will start with alcohol. अल्कोहल को ट्रीट कीजिए आप सोडियम के साथ. इट्स गोइंग टू गिव यू RONA plus H2 gas is going to be liberated. Now this is the sodium alkoxide. ठीक है, now this sodium alkoxide will be used with any alkyl halide R-X. The oxygen atom which is having lone pair as well as a negative charge because sodium is having sodium positive, this O is going to attack on the alkyl group of halogen and SN2 reaction takes place, it's going to give you ROR dash plus you will get NaX. So there are some simple examples. इसको कीजिए. For example, if you have 2 carbon atoms and then OH, the first step you have sodium, the second step you have CH3Br. ठीक है. तो अभी क्या करना, हाइड्रोजन को हटाना है और जो अल्काइल ग्रुप लगा हुआ है ना एलो एल्केन में, दैट अल्काइल ग्रुप यू हैव टू ऐड. ठीक है. सो लेट अस सपोज आई एम राइटिंग दिस इन रेड. ठीक है. और ये आपके पास किसमें, ब्लू में लिख देते हैं इसको. आई एम राइटिंग दिस CH3Br इन ब्लू. So in the red one, you will write everything as it is apart from the hydrogen. हाइड्रोजन को छोड़ के सब कुछ वैसे लिखिए. Just copy. ठीक है. Oxygen आ गया. And what is the alkyl group in CH3? The alkyl, sorry, in this particular haloalkane, the alkyl group is CH3. So you will write CH3 like this. This is how you are going to make the product. ठीक है. देखिए इसमें आपके पास थोड़े से complications आ सकते हैं. Second is again going to be easy, not very tough. For example, if you have ONA like this, और यहाँ पे आपको दिया हुआ है 2 carbon atoms and iodine, then यहाँ पे आपको everything as it is till oxygen atom. So you wrote everything as it is till oxygen atom, and then oxygen में क्या रहेगा, whatever alkyl group is attached on this haloalkane. So what alkyl group? You have 2 carbon atoms. It is ethyl. So you are going to get this type of molecule. Now, for example, if you have something like this, 2 carbon atoms, and then you have ONA. And here you have 2 carbon atoms and let us suppose Br. So you write everything as it is till the oxygen atom, and then whatever alkyl group is attached on the haloalkane. So 2 carbon atoms. So यहाँ पे आपके पास ethyl आ गया. Now you can have something cyclic also. You have ONA, and here you have CH3Br, CH3Cl. So everything as it is till oxygen atom, and then oxygen will have the alkyl group of haloalkane like this. Chaliye, please copy this down. Raise your hand once you are done. Just waiting for Arsalan now.
Yes, sir, done.
See here, guys. Write some remarks. First point is the Williamson ether synthesis is an SN2 reaction where alkoxide ion is nucleophile and haloalkane is substrate. ठीक है. Therefore, ठीक है, ध्यान रखिएगा, न्यूक्लियोफाइल कहाँ अटैक कर रहा है, haloalkane में. तो SN2 रिएक्शन के लिए व्हाट डू यू थिंक, what will be more favored? SN2 reaction में haloalkane should be hindered or not hindered? Tell me. It should be more hindered or less hindered? The haloalkane should be less hindered or more hindered? Tell me, guys. For SN2 reaction. SN2 के लिए रेट ऑफ रिएक्शन किसका सबसे ज्यादा फास्ट होता है? 1 डिग्री, 2 डिग्री, 3 डिग्री में, विच
One.
शोज 1 ना, तो यानी कि लेस हिंडर्ड होना चाहिए। मेक सेंस? यस और नो? ठीक है। देयरफॉर द Rx should be less hindered. Rx should be less hindered, यानी कि प्लीज सी, जो भी हम लोगों ने यहाँ पे जो भी हम लोगों ने यहाँ पे ethers बनाए हैं, in ether we have two alkyl groups, right? In all the ethers we will have two alkyl groups. All our ethers are having two alkyl groups, na? Two alkyl groups. One of the alkyl group, it is coming from the haloalkene, and the other alkyl group is coming from alcohol या फिर alkoxide ion. Make sense? Yes or no? Please tell me. Correct है? सही
Yes,
है?
sir.
ठीक है। तो यानी कि आपको अगर अनसिमेट्रिकल बनाना है, इज राइट, ध्यान से इस पॉइंट को लिखिएगा, आपको समझ में आ जाएगी बात। ठीक है, ध्यान से लिखिएगा इस पॉइंट को। सेकेंड वन प्लीज राइट, टू फॉर्म unsymmetrical ether, 1 degree alkyl halide should be taken preferably. 1 degree alkyl halide क्यों लेना चाहिए? क्योंकि it is SN2 reaction, and in SN2 the haloalkene, the substrate should be what? It should be less hindered. Third point, usage of 2 degree and 3 degree haloalkane leads to formation of alkene as they are more hindered. ठीक है, बट प्लीज रिमेंबर वी कैन यूज 2 डिग्री 3 डिग्री एल्कोक्साइड आयन। ठीक है, क्या लिखेगा इसके बाद? फोर्थ पॉइंट, देयरफॉर 2 डिग्री और 3 डिग्री alkoxide ion can be used. ठीक, ध्यान दीजिए जरा। लेट अस सपोज आपको क्या बनाना है, ध्यान दीजिए, यू हैव समथिंग लाइक दिस। ठीक है, यू हैव टू मेक समथिंग लाइक दिस। अच्छा, एक काम करते हैं, ऑक्सीजन को यहां रख लेते हैं। ठीक है, टू मेक समथिंग लाइक दिस, now you identify the carbon atoms which are attached to oxygen. So this is one of the carbon atom and this is one of the carbon atom. Now let's suppose इसको blue कर दिया हमने। This blue carbon atom, it is what? It is 2 degree, and this red one, it is 1 degree. ठीक है, so this alkyl group which is 2 degree, this should come from RONA। ठीक है, और ये जो आपके पास alkyl group है, this alkyl group 1 degree वाला, ये किसके साथ आना चाहिए? This should be coming from haloalkane. So the preferred starting material or the substrate and reagent that we should use is ONA plus 1 carbon, 2 carbon atoms, halogen, any halogen, Br. ठीक है, this is going to give you O, unlike this. Does this make sense? Yes or no? Please tell me. ये बात सबको समझ में आई कि लेस हिंडर्ड वाला हैलोएल्कीन होना चाहिए, मोर हिंडर्ड वाला एल्कोक्साइड। हाँ जी, कृष्ण प्रिया, सफिया एंड अरसलान।
Yes, sir.
Yes, sir.
सफिया, व्हाट अबाउट यू? आपको समझ में आया?
Yes, sir.
ठीक है, done writing? ठीक है। Now similarly, if you want to make phenyl alkyl ether, समथिंग लाइक दिस। तो यहाँ पे आपके पास यू कैन यूज दो पॉसिबिलिटीज है इसके ना। क्या क्या पॉसिबिलिटीज है? आइदर यू यूज फेनॉक्साइड आयन ONA प्लस RX, इससे मिल सकता है आपको, और यू यूज aryl halide, that means halogen atom is here, plus you use alkyl, you use alkoxide ion RON. ठीक है? Now the problem in the second one is that this halogen atom will be in resonance with the benzene ring, and the CX bond is going to be partial. It will have partial double bond character, has partial double bond character. Therefore, it is difficult to break. Therefore, it is difficult to break. है ना? So, in the case of alkyl, sorry, in the case of alkoxybenzene, this is alkoxy group, and this is benzene. In case of alkoxybenzene, what we should use? We should use phenoxide and alkyl halide. ठीक है? So phenoxide and alkyl halide are used to prepare alkoxybenzene. Alkoxybenzene का जो बहुत ये एग्जांपल है ना, विच इज जनरली आस्क्ड इज एनीसोल। ऑक्सीजन पे CH3 ग्रुप लगा हुआ रहता है, ठीक है? फेनॉक्साइड एंड अल्काइल हाइड आर यूज्ड टू प्रिपेयर alkoxybenzene, है ना? दिस इज नॉट यूज्ड। अराइल हाइड and alkoxide are not used due to above reason. Reason क्या? That is haloarenes don't show SN ये शो ही नहीं करते। ठीक है? इसके बाद एक और पॉइंट लिखिएगा इसी में। फॉर एग्जाम्पल, इफ यू वांट टू प्रिपेयर ditert butyl ether, that is carbon with 3 CH3 groups, oxygen, and then carbon again with 3 CH3 groups. ठीक है? Now for sure, now both of these carbon atoms are what? These are 3 degree carbon atoms. So for this you will need alkoxide, which is 3 degree, and you will also require alkyl halide, which is 3 degree. And since when you are going to use 3 degree haloalkane, it is going to give you alkene. That is why we cannot prepare this molecule. ठीक है? So you'll write ditert butyl ether cannot be prepared with Williamson ether synthesis, as it would require 3 degree haloalkane, which results in formation of alkene. Can I write this question? Should I do one for you guys? बताइए. For
Yes,
this question,
sir.
tell me Krishna Priya Safiyan Salam. Yes, which one? Tell me. कौन सा कर दे?
Sir, third वाला.
थर्ड वाला. ठीक है. सबसे पहले तो नाम देखते हैं इसका. This is 2-methoxy 2-methyl propane. ठीक है. So first of all, you will identify the longest carbon chain. It is prop. तो 3 कार्बन आटम बना लीजिए. 1 2 3. That is saying 2-methoxy. Second carbon पे क्या लगा हुआ है? You have methoxy group. That means OCH3 group is present in the ये कार्बन आटम है ना. सेकंड कार्बन आटम. और सेकंड कार्बन आटम भी क्या लगा हुआ है? मीथाइल लगा हुआ है. You have CH3 like this. ठीक है. तो विलियमसन ईथर सिंथेसिस में you will require one haloalkene and you will require one alkoxide ion. ठीक है. So after this, what you need to do is identify the carbon atom, the degree of carbon that is attached with oxygen atom. तो इसकी बात अगर हम करें, this is tell me what degree it is. This carbon atom is 1 degree, 2 degree, 3 degree. क्या है ये?
Sir, 3 degree.
3 degree. Very good. And what about this carbon atom? This carbon is attached to how many carbon atoms? Tell me.
Sir, 0.
0 है ना. तो 0 डिग्री 1 डिग्री आप लिख लीजिए. 0 डिग्री कोई दिक्कत की बात नहीं है. ठीक है. सो एज यू नो, एल्कोक्साइड आयन और मतलब हैलो एल्केन में हैलो एल्केन शुड बी लेस एंडर्ड. ठीक है. तो इसके लिए यू हैव टू यूज व्हाट? CH3 Br प्लस बचा हुए से एल्कोक्साइड बना लीजिए ONA. बस हो गया. दीज आर द मॉलिक्यूल्स व्हिच विल बी यूज्ड. इसको कैसे नाम देंगे आप? दिस इज व्हाट? दिस इज मीथाइल ब्रोमाइड. मीथाइल ब्रोमाइड. या फिर आप इसको ब्रोमोमीथेन भी बोल सकते हैं. एंड दिस इज व्हाट? दिस इज टर्ट ब्यूटाइल एल्कोक्साइड. टर्ट ब्यूटॉक्साइड. टर्ट. हाँ. टर्ट. ऐसे लिख लीजिए. TERT. टर्ट ब्यूटाइल एल्कोक्साइड कर लीजिए. ठीक है. सो दीज आर द टू substrate and reagent that we are going to use. Make sense? Yes or no? कैसे करना समझ में आया?
Yes, sir.
डिग्री देख लीजिए बस. जो कम डिग्री का है वो हैलो एल्केन हो जाएगा. जो ज्यादा डिग्री का है वो क्या हो जाएगा? इट विल बी एल्कोक्साइड. Do it. I'm going to give you guys, I think 4 minutes will be enough. Once you're done, you will send the answer on my WhatsApp. Okay, send me whatever you have done till now. गाइस एक तो क्या होगा, कम से कम जल्दी भेजिए. Send me whatever you have done. Krishna Priya, you have not sent anything. विलियमसन ईथर सिंथेसिस से चाहिए भाई. असलान.
Yes, sir.
अच्छा ओके कृष्ण प्रिया. Okay, that is correct. See, whenever you have been given this type of question ना कि product से आपको reactant बनाना है, then first of all make the product. First में देखिए आपको क्या, 1 propoxy propane, so 1 2 3 carbon atoms bonded to oxygen, and then 1 2 3 carbon atoms, right? Propoxy propane. तो इसमें से एक alkyl group will be from alkoxide and दूसरा कहाँ से आ जाएगा, haloalkane, because both of them are what, this is also 1 degree and this is also 1 degree. So we can write 1 2 3 carbon atoms ONA plus 1 2 3 carbon atoms Cl. Both of these will react and it's going to give you this molecule. Second में आपके पास क्या है, you have ethoxybenzene. O, then 2 carbon atoms. We have just seen that phenoxide को use करेंगे because we cannot use haloarine. और ऐसे भी ना यहाँ पे भी you can use that idea of more degrees. So this is going to be 2 degree carbon ना. इस वजह से you can use phenoxide याद रखने के लिए, but even though 2 degree is not the real reason, and then 2 carbon atoms, you can write any halogen atom. It is going to give you the molecule. Then we have 1 methoxyethane. 1-methoxyethane. अच्छा, CH3, CH2, and then OCH3, methoxyethane. तो यहाँ पे आपके पास the larger one is going to be phenoxide, alkoxide, CH3, CH2, ONA plus CH3, iodine you can take and do the reaction. तो see, आप ये देखिए कि if you are fast, if you are good at, if you have command over writing the structure from name, तो फिर आपके लिए सारे सवाल बहुत आसान हो जाएंगे, ठीक है. बट इफ यू आर नॉट कंफर्टेबल विथ गोइंग फ्रॉम नेम टू मॉलिक्यूल, नेम टू स्ट्रक्चर, इट विल बी डिफिकल्ट फॉर यू गाइस. ठीक है, तो इस पे आप लोग थोड़ा ध्यान दीजिए, लाइक हाउ टू गो फ्रॉम स्ट्रक्चर और टू गो फ्रॉम नेम टू स्ट्रक्चर. चलिए, राइट दिस डाउन, रेज योर हैंड वंस यू आर डन. आई एम लोअरिंग योर हैंड्स राइट नाउ. प्लीज रेज योर हैंड वंस यू आर डन. All of it, ठीक. After this, you will write physical properties. Is there any more questions that you can have? Just give me a second, let me think. I don't think so. ठीक है. Yeah, write physical properties. Now, in physical properties, the structure of ether is something like this. So, because we have two lone pair electrons here, and this oxygen atom will be slightly delta negative, this molecule is slightly polar, not very polar, but it is slightly polar. Slightly polar. You'll write here, ethers have lower boiling point than alcohol due to the absence of hydrogen bond in ethers. Okay, hydrogen bond is not present. Then you write next one. Boiling point of ethers is slightly more than hydrocarbons of similar molar mass. That is only because hydrocarbons are completely non-polar. And the last point, ethers are soluble in water as they can form hydrogen bond with water. So ether, they don't form hydrogen bond with themselves, but they can form hydrogen bond with water. How is it possible? It's possible because we have HOH in water, and in ether we have oxygen, which is having lone pair electrons. So this hydrogen atom, which is having highly delta positive charge, interacts with the oxygen atom like this, and this leads to formation of the hydrogen bond between water molecule and ether, which leads to the solubility of ethers. And same point as we have seen many times, increase in number of carbon atoms decreases the solubility of ether. Just waiting for Krishna Priya now. After this, right, chemical properties. In chemical properties, the first type of reaction is cleavage of CO bond. Okay, cleavage of CO bond. In this, we are going to see reaction with hydrogen halide. It forms alcohol and haloalkane. जैसे विलियमसन ईथर सिंथेसिस में जो हो रहा था उसी का जस्ट अपोजिट समझ लीजिए. बट इन विलियमसन ईथर सिंथेसिस वी यूज्ड अल्कोक्साइड रादर देन अल्कोहल. बट अल्कोक्साइड भी कहां से आता है? अल्कोहल से ही आ रहा होता है. ठीक है. सो व्हाट इज हैपनिंग हियर? वी आर हैविंग R O R dash and then we are adding HX. So oxygen, it is joining with hydrogen, and this alkyl group is getting the halogen atom, which leads to the formation of ROH plus R dash X. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
ठीक है. अब यहाँ पे अलग अलग केसेस आ जाते हैं. ठीक है. दैट व्हेन यू हैव सिमेट्रिकल, देन इन दैट केस तो आपको वहां पे कुछ देखने की जरूरत है नहीं, बिकॉज वन ऑफ देम इज गोइंग टू गेट द हाइड्रोजन, द अदर इज गोइंग टू गेट द हाइड्रोजन एटम. ठीक है. बट जहां पे अनसिमेट्रिकल होगा वहां पे आपको देखने की जरूरत है. ठीक है. अनसिमेट्रिकल में सबसे पहले है ए केस पहले देख लीजिए आप. जब व्हेन यू हैव सिमेट्रिकल ईथर में क्या होगा? फॉर एग्जांपल, इफ यू हैव 2 कार्बन एटम्स and here also 2 कार्बन एटम्स and you are treating this with HBr, तो आपको मिलेगा OH plus 2 कार्बन एटम्स का haloalkane. Secondly, if you have CH3, OCH3, you react this with HI. Here you will get CH3I and CH3OH. ठीक है. So यहाँ पे you will not have any problem. You will get एक alkyl group से haloalkane, दूसरे से, I mean same ही है, I mean the same alkyl group, you will have alcohol. B is, please write, unsymmetrical ether. Unsymmetrical ether. Now in unsymmetrical ether, we are going to have some cases. सबसे पहला आपको क्या करना है? First of all, you will see whether you have any 3 degree alpha carbon. ठीक है. क्या देखना सबसे पहले आपको? ए केस में आपके पास नंबर 1 में check for 3 degree alpha carbon. If you have 3 degree alpha carbon, then that carbon is going to get the halogen. check for 3 degree alpha carbon. If yes, then that carbon would get the halogen. ठीक है, यानी कि for example, if you have 1 2 oxygen and then you have 2 carbon atoms like this. Now you see this is a 1 alpha carbon. This alpha carbon is what? It is 3 degree. This is 1 degree. ठीक है, तो 3 degree वाले को क्या मिल जाएगा? 1 2 3. It is going to get the, let us suppose you have HI, it is going to get the iodine plus 2 carbon atoms, you will get the OH. Does this make sense? Yes or no? Please tell me, guys.
Yes.
हाँ जी बताएं. ठीक है, ऐसी एक आपके पास सवाल है, उसकी को भी हम अभी देख लेते हैं. काम करते हैं, सवाल को ना आखिरी में देखते हैं, सारे डिस्कस करके ना, देन आपको कंक्लूजन सही से समझ में आएगा. ठीक है, अभी इसको छोड़ देते हैं. ये तो पहला केस आ गया, व्हेन इफ यू हैव 3 डिग्री अल्फा कार्बन. सेकंड इज, अगर आपको 3 डिग्री अल्फा कार्बन मिल गया तब तो बहुत अच्छा, तुरंत हो जाएगा. ठीक है, यू विल डायरेक्टली आंसर इट. बट नेक्स्ट केस इज इफ only 1 degree or 2 degree alpha carbons are there, alpha carbons are present, then the carbon with lower degree will get halogen and the other would form alcohol. ठीक है, ध्यान दीजिए जरा. So for example, if you have 1 2 oxygen and then you have like this. Now this carbon atom, it is what? It is 2 degree. This carbon atom, it is 1 degree. So 2 degree और 1 degree में हाइड्रोजन एटम किसको मिलेगा? 1 डिग्री वाले को. सो दिस 1 डिग्री इज 2 कार्बन एटम्स, सो यू विल हैव 2 कार्बन एटम्स जॉइंड विद, इट इज सपोज यू हैव HI, तो आपको क्या मिलेगा? आयोडीन यहाँ पे, प्लस द रेस्ट ऑफ द फ्रैगमेंट यू विल राइट एज इट इज, और इसको OH मिल जाएगा. डज दिस मेक सेंस? यस और नो? प्लीज टेल मी गाइस.
Yes, sir.
ठीक है, नेक्स्ट केस है आपका. Next case is this one, alkoxybenzene. In alkoxybenzene, we get phenol and RX. तो आपके पास अगर you have O and alkyl group, when you treat this with HI, see, breaking of this bond is very difficult now. Why? Because this is going to be showing resonance. So oxygen atom will be in resonance, so the CO bond is difficult to break. That is why which bond will break? The CO bond of alkyl group is going to break, and you will have OH plus RX. CO bond of benzene has partial double bond character due to resonance, therefore difficult to break. ठीक है, फोर्थ इज बेंजाइल alkyl ether. Benzyl alkyl ether gives benzyl halide and alcohol. ठीक है, So what is benzyl? Benzyl is a benzene ring with a CH2 group. And alkyl ether will be OR. When this is treated with HI, you will be getting benzyl halide, that is CH2 bonded with iodine, plus you will get ROH. फिफ्थ वाला है आपका डाईअराइल ईथर. Diaryl ether don't give any product as both CO bonds are difficult to break. What is diaryl ether? You have benzene ring, O, and then you have again a benzene ring in the presence of HI. Now this is also having double bond character. This is also having double bond character. That is why there will be no reaction. Copy this down itna. All of you are done. Yes, Safia Arslan, Krishna
Yes,
Priya.
sir.
Yes, sir, just a few more lines.
Raise your hand once you're done. Okay, Arslan. I have lowered your hand.
Yes, sir. Sir, I'm done.
Let us see some questions. Give the major products that are formed by heating each of the following ethers with HI. ठीक है, ध्यान दीजिए. सबसे पहले you see here, see this carbon atom, it is what degree? Tell me guys, this carbon atom is what degree? अरे बोलो तो.
Sir, 1 degree.
1 degree. And what about this carbon atom?
Sir, 1 degree.
This is also 1 degree. ठीक है. अब इसमें से बताइए which is less hindered, blue or red? Which is less hindered? Guys, any idea? Which is less hindered, guys? Blue or red? Look at the groups attached, no? Look at the groups attached and tell me. Safia, आपकी आवाज नहीं आ रही. You're turning the mic on, but I can't hear you.
Sir, red.
Red is less hindered. So less hindered वाला क्या हो जाएगा? Alkyl halide, no? When you have 1 degree, 2 degree, तो lesser degree वाला. Lesser degree मतलब less hindered one. So the products that you will be getting is CH, sorry, my bad. CH3, CH2, CH, CH3, CH2 and OH plus you will get CH3, CH2, and iodine. So for the first one. Now, this is what degree, tell me guys. The blue one is, बोलिए लिखिए मत अभी, लिखने का काम अभी नहीं. Tell me guys, this blue one is what degree?
1 degree,
1 degree. And this carbon atom?
2 degree.
3 degree.
3 degree है ना, देखिए जरा ध्यान से सफिया.
Yes, sir.
ठीक है, तो 3 degree में we know that जब 3 degree हुआ then the halogen atom will attach to the 3 degree. Second वाले में क्या हो जाएगा? You will have CH3, 1 2 3 carbon atoms, 1 2 3 carbon atoms, and then OH, plus you will have 1 2 3 carbon atoms, 1 2 3 carbon atoms. This carbon atom will have halogen, एक carbon इधर और दूसरा carbon इधर, CH3 and CH3 here. ठीक है, the halogen is going to be iodine, to be specific. Make sense? Yes or no? Please tell me guys.
Yes, sir.
ठीक है, अब ये थर्ड वाला देख लीजिए. सी दिस बॉन्ड तो कैनॉट बी ब्रोकन. मेक सेंस? यस और नो? प्लीज टेल मी. ये वाला बॉन्ड तो नहीं टूट सकता ना, बिकॉज इट इज गोइंग टू बी इन रेजोनेंस. ऑक्सीजन एटम इज गोइंग टू शो रेजोनेंस लाइक दिस ना. सो दिस बॉन्ड विल हैव पार्शियल डबल बॉन्ड कैरेक्टर. तो कौन सा बॉन्ड टूटेगा? ये वाला टूटेगा. ठीक है, एंड यू विल गेट OH और यहाँ पे हाइड्रोजन आ जाएगा. सो विल हैव बेंजीन रिंग विथ OH प्लस CH2, and here you will get iodine. So you copy this down, raise your hand, once you are done. Everyone is done?
Yes, sir.
Next, you write electrophilic aromatic substitution of anisole. ठीक है, ध्यान दीजिएगा. You write here first of all alkoxy group is an activating group which increases the electron density of benzene ring at ortho and para position, leading to formation of ortho and para products. After this, you will write these reactions. है ना, ये reactions वही सारे पुराने reactions हैं. We have bromination, Friedel-Crafts alkylation, Friedel-Crafts acylation, nitration. It does not give sulfonation reaction. We will tell you why. Write this down. These 4 reactions are given by anisole. Then all of you, yes or no, please tell me.
Yes.
Then take no. Right remarks. These reactions are not new, na? आप लोगों को these reactions just now in phenols also, right? याद है ना आप लोगों को? हाँ जी,
सर
अरसलान, सफिया एंड कृष्णा प्रिया. हाँ
Yes.
सफिया, बोलिए बोलिए.
आप थोड़ा ऊपर कर
सफिया,
सकते हैं?
नहीं आवाज नहीं आ रही है ठीक से आपकी. Yes, Safia, you are saying something.
नहीं बस थोड़ा ऊपर कर सकते हैं क्या?
ऊपर, हाँ जरूर. देखिए, whenever you are trying to speak ना, please turn your mic on. Don't use the space bar button. स्पेस बार से समझ ही नहीं आता, हमको तो नहीं आता, भले ही आपके दूसरे टीचर्स को समझ में आता हो, इस वजह से आप लोग यूज करते हैं, बट हमें समझ में बिल्कुल नहीं आता क्या बोलना चाह रहे हैं आप, है ना. अचानक से ब्रेक हो जाता है. डू आई नीड टू स्क्रॉल अ बिट मोर अप, सफिया?
नहीं सर खत्म, थैंक यू।
ओके, ठीक है. राइट रिमार्क्स. right here. First of all, due to highly activating plus M group, any highly activating plus M effect of alkoxy group bromination doesn't require any catalyst such as FeBr3. Another point is anisole doesn't show sulfonation as the presence of concentrated H2SO4 protonates the ethereal oxygen atom, and the benzene ring gets deactivated. ठीक है. बेसिकली होता क्या है, यू हैव anisole like this, OCH3. ठीक है. When you react this with concentrated H2SO4, you have OCH3, and here you get hydrogen. This oxygen atom will get a positive charge. Now, as it gets a positive charge, it is going to pull the electron density from benzene ring, and that is why this benzene ring will not be able to attack on the electrophile. Okay? That is why it does not show sulfonation reaction. Write this 2 point. Raise your hand once you're done. Then Safia, Krishna Priya, and Arsalan.
यस सर।
Yes, sir.
So please revise करते रहिए आप लोग, है ना. And tomorrow we will start seeing all the alcohol, phenols, and ether is over. Tomorrow we will start with aldehyde, ketone, and carboxylic acid. ठीक है. In the next class we will be starting with aldehyde, ketones, and carboxylic acid. We have done a lot of portion today. We have done complete ethers, and ethers is very important portion. अगर आप alcohol phenols ether prepare कर रहे हैं and you are not revising the ether portion, सोचिए कि छोटा सा portion है, लेकिन आप यहाँ पे देखिए कितने सारे y type of questions बन सकते हैं, right? If you start, सबसे पहले अगर आप start करें, then the first reaction here you will have dehydration of alcohol में at higher temperature we get alkene, at lower temperature we get ether. ठीक है? Then next is the mechanism. यहाँ पे after mechanism you will see that the rate of reaction. So this question can be asked from here. Then they can ask you why 2 degree and 3 degree alcohol give significant amount of alkene, because they are more hindered. Why this method of preparation is not suitable for the preparation of unsymmetrical ethers. This is one question. Then this one question can be asked in a different, completely different language also. Generally बच्चे identify नहीं कर पाते. That is, bimolecular dehydration is not a suitable method to prepare ethyl methyl ether. Why? ठीक है? Then you have Williamson ether synthesis. In Williamson ether synthesis also you have multiple Y type of question that can be asked. कि first सबसे पहले तो ये what type of reaction is this? SN1 SN2 elimination क्या है? It is SN2. Now in order to form unsymmetrical ethers, why 1 degree alkyl halide should be taken preferably, because it is a substrate and the reaction is happening via SN2. ठीक है? After this, why aryl halide and alkoxide cannot be used? Why aryl halide and alkoxide cannot be used to form alkoxybenzene? ठीक है? See, all of these Y type of questions can be asked. तो ये जो ethers वाला